Okay, I am 1. This is a little explanation on the answer to our question, like what do we mean when we get negative or 0 exponents? So here's an example of x to the 7th over x to the 10th, and we could write this out in expanded form, and we would get 7x's on the top and 10x's on the bottom, and using our expanded form method, all these x's will cancel, and then what's going to happen is we run out of x's on the top, and so we're just left with a 1, and then we have 3 x's on the bottom still, so we're going to end up in this case with 1 over x to the 3rd power. So that's one way to demonstrate it. And we've also just learned the rule that says x to the 7th over x to the 10th is the same as x to the 7 minus 10, because what we're basically doing is taking our 7 x's on the top, taking away 10 of them from the bottom, and then we're going to be left with this confounding, what does it mean to repeat something negative 3 times? Well, because we just demonstrated the answer correctly using 2 different methods, then it means that these 2 things must be equal. So x to the negative 3rd is equal to 1 over x to the positive 3rd. And that right there is our rule. The rule says that if you have any base, x, to any exponent that's negative, like negative anything, n, it can be rewritten as the reciprocal 1 over x to the positive n. So an example would be, if you have 4 to the negative 2 power, excuse me, that doesn't mean 4 repeated negative 2 times, because that's impossible. What it means is you flip it over and say 1 over 4 to the positive 2 power. Those things are equivalent. And what we generally want to do is, it's okay to have negative exponents as you're working through the solution to a problem, but you want to leave it in a form in which all exponents are positive in your final answer. Okay, well that also brings up to the special case of what if we had something like x to the 7th over x to the 7th? Well, right off the bat you could probably be looking at this and say, well, that's something over itself, which will give us 1. And we're going to prove that right now. So there's, using repeated factor form, we cancel out x's, and then it turns out they both run out at the same time, so we're basically left with 1 over 1. 1 over 1 equals 1. Now, using our rule of dividing exponents means subtracting the exponents, we would get x equals 7 minus 7, which is x to the 0 power. Well, again, this can be a confusing result because what does it mean to repeat something 0 times? Well, we solved this 2 times using 2 correct methods, and so what it must mean is that these 2 things are equal. So what we've just shown is that x to the 0 power is equal to 1. And that's true for all bases. Anything to the 0 power equals 1. There's some debate, and you can go out and Google it, as to, well, what if it's 0 to the 0 power? Is that 1? And for our purposes, we're going to say it's 1, but you can Google it, and there's a debate out there about whether that's true. And so as an example, if you have something like 4 to the 0 power, well, that's just equal to 1 because of this proof above.